So our next question is the number of significant figures in Avogadro's number is. Our options are A4, B2, C3, and D. None of this. So let's write the Avogadro's number and check the number of significant figures in the Avogadro's number. We all know that Avogadro's number has a value of 6.022 into 10 raised to power minus 23. Here, as they have given the Avogadro's number and as they were asking the number of significant figures, so we are going to count the number of significant figures in the given value. So we have 1, 2, 3, 4. Therefore, we have 4 significant figures in the Avogadro's number. The right answer for this question is option A, which is 4. Next, A refers to the closeness of various measurements for the same quantity and B is the agreement of a particular value to the true value of the result. A and B respectively are. Here they have given us the definition of few terms and they are asking us to find out what is A and what is B. As we can see, A refers to the closeness of various measurements for the same quantity. Here A is defined as precision. So A is going to become precision and B is the agreement of a particular value to the true value of the result. So B is going to become the accuracy. So the right option for this question is option C, which is A is precision and B is accuracy. So our next question is, which of the following is the most accurate measurement? We have been given 4 options: A 9 meter, B 9.0 meter, C 9.00 meter and D 9.000 meters. Here all our values are same and all our values are having the value as 9, but they are asking us which is more accurate. The one who is having more number of significant figures is going to act as more accurate. When you see the option A, there is only one number, so it is going to have only one significant figure. In option B there are two significant figures, in option C there are three, and in option D we have four significant figures. As option D is having more number of significant figures, this is going to be the most accurate measurement for the given question. So the right answer for this question is option D, which is 9.000 meters. Next, given that the true value for a result is 2.00 gram, three students A, B and C take two measurements and report the result. Data to illustrate precision and accuracy as given below. So which of the following students got the values which are both precise and accurate? So they're asking us in among the three students who is precise and who is accurate. We know that precision is always the values which are close enough to the same quantity and accuracy is the particular value which is going to have a true value to the closeness of a final value. So as we can see in option A, which is in student A, 1.95 and 1.93 are very far away from the true value and the average value is also very far from the true value. So he is not going to be precise as well as accurate. When you look into student B, he is having values 1.94 and 2.05. Again, these values are not precise as he is being very far from the true value, and 1.95 is very much accurate as he is having the average value but still is very far. So we can't consider. But when it comes to student C, he is having two values which is 2.01 and 1.99. Both these values are being very close to our true value which is 2.00. So hence student C is precise and his average value which is 2.00 is exactly the true value which we wanted, which is 2.00. So hence student C is acting both precise and accurate. So the right option for this question is option C, which is student C. Next, look at the addition of significant figures given below. The result reported in this addition should be. As they are asking us to follow the addition of significant figures, we should always remember one rule, that is addition of significant figures rule. In this, while solving this problem, we have to make sure among the three factors which is given here, that is 12.11, 18.0 and 1.02, the one who is having the least number of significant figures should also correspond to the answer. For example, here when it comes to 12.11, we are going to have how many significant figures? 4 significant figures are available. When it comes to 18.0, we have three significant figures. And when it comes to third factor, we have four significant figures again. Here, 18.0 is the one who is having least number of significant figures. Hence, our answer should also have three significant figures. So, we are going to round it off to 31.1. So, this 31.1 is having three significant figures, and these significant figures are going to correspond with the question what we are having here, which is containing the least number of significant figures. So the right answer for this question is option B, which is 31.1. Next, the result reported in the following multiplication of significant figures: 2.5 into 1.25 is equal to 3.125 should be. Here again we have to follow the significant figures rule. The question is having the least number of significant figures, the same number of significant figures has to be applied to even to the answer. In the question we have two factors, one is 2.5 and 1.25. 2.5 is having two significant figures and 1.25 is having three significant figures. So as 2.5 is the one who is having least number of significant figures, so the answer should also contain two significant figures. So the right answer for this question is 3.1, which is option B. Thank you. So these questions were referred from NCERT and Harian publications.